Hey guys, today I'm going to be explaining to you and going into depth the periodic table and its electronic configuration. So first we have to divide our elements with groups. So basically right here is the S group, right here is the D group, right here is the P group, and right here is the F group. Now we're just going to highlight the groups to be more organized. So again, this is the this is the S group. Oh my gosh. Yeah, this is the S group. Now we're gonna label the D group. You're gonna save these two elements for later. So you're just gonna put it like this. That's a D group. Now this is the P group. Wait. Oops. OMG. This is a P group. Oh, I'm sorry, Mr. T. This is the P group. Oh, also, helium is a part of the S group. So I'm going to highlight this blue. Okay, now let's label the F group. This is the F group. And also this too. This is a part of the F group. Okay. Now that we have everything labeled, now we're going to go through the energy levels. So, the energy levels are 1, 2, 3, 4, 5, 6, and 7. Now, for here, let me see if I can. For this, it also has this level, but you have to remember this, n minus 1. So, n minus 1 basically means, so 4 minus 1 is 3. So right here we'll start from 3. 5 minus 1, 4. 6 minus 1, 5. And 7 minus 1 is 6. So that's how you classify your energy levels. And then, yeah, it's kind of different because for only this, it's n minus 2. So basically, like 6 minus 2, what would it give you? 4. And what would 7 minus 2 give you? 5. So that's how you label your periodic table. So these are our levels. And now they also have columns. So this is column 1, column 2, column 3. This is column 4, 5, 6. Move the T group. This is column 7, column 8, column 9, 10, 11, 12. Let's move this. Column 13, column 14, 15. 16, 17, and 18. So yeah, that's how our columns are organized in the periodic table. Okay, to find the valence electrons, for example, let's go to column 14. I'm gonna do it on here. So here it'd be, to find it, 14 minus 10, which would give you 4. So basically, right here, this column, you would have 4 valence electrons. Now let's say I go from this column 17. 17 is 17 minus 10, which would give you 7 valence electrons right here. So here you would say they have 7 valence electrons, and here it'd obviously be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Always remember that you only subtract 10 with, let's erase everything. Always remember that the minus 10 only applies to 10. Hold on. 10 and 18 should be minus 10. That's when I'm finding valence electrons for the columns. And then, wait, no. It doesn't start from 10, it starts from 11. Right here. Okay, no. Negative 10. That's how you find out valence electrons. So you also have to remember that let me move this up. So right here to here, you have to also remember that it's 1 to 3 valence electrons. Okay, now we're gonna find the electron configuration of aluminum. Let's put this color. We're gonna do the color let's do purple. So A9. Now to do this, we're gonna use our periodic table. So let's say, you see how this is row 1? We're gonna put 1. I'm talking about this. So row 1, and since it's in the S group, I'm gonna put 1S. Now that I put 1S, we also have to see what else is left on the S group. And if there's anything, we have helium. So for helium, we're gonna cross that out. And since it's the same thing, because it's still 1S, we're just gonna put 2 right here. Okay, now we're gonna go to the next level, which is row 2. So we're gonna put 2, and here we have 2 in the same, so they're two, like they're the same, not that they're the same element, I'm just saying that they're in the same like row, you know? So 2, the same thing, 2, how we did in the first one, 2S, 2. And because we still have the S there because it's still in the S group. Okay, now that we're moved on, now that we cross these out, we're still missing, in the same row of 2, we're still missing all of this. But now since we moved, we're not going to use the S anymore. It's still 2 because it's in row 2, but now we're in P. So it's going to be 2P. Let's count them. 1, 2, 3, 4, 5, 6. So right here, I'm going to put 6. Okay, also keep in fact that we're trying to find aluminum. So the atomic number is 13. By the end of this, all these numbers should add up to 13 because it's an atomic number of aluminum. Now since we're done with the S row, we're gonna okay, so now since we're done with row 2, we're gonna go to row 3. Okay, so now since we finished row 2, now we're gonna go to row 3. So it's the same process. Okay, so So basically, we're in row 3 now, right? So we have 2 in the S group. So we're gonna say in row 3. So we're gonna say 3 S2, and now we're gonna move to P group because that's what's next. So, oops. Okay, so now that, like, if we were trying to find, for example, sulfur, we would go 1, 2, 3, 4, and then we put 3P4. But here we're trying to find aluminum. So what we're gonna do is, if I have to find this, I'm not gonna add extra. No, I'm just here for the aluminum. So we only have to do 1. So it'd be 3P1. And now you see this on top. This should equal 13. Let's count it. So 2 plus 2, 4 plus 6, 10, and 2 plus 1 is 3. What does that give you? 13. So this is how you find your electron configuration using the periodic table. Okay, so now we're gonna get our electron configuration and we're gonna label it with the shapes that they're supposed to go with. So I'm gonna explain it right now. So if you're in the S group, so the S would give you a circle, P would give you a dumbbell, and D would give you the 4-leaf clover. Okay, now F obviously has its own thing, but we're not using that right now, so we don't care about it. Now, let's see how we do this. So since this is S, we have one circle. This is S2, so another circle. This is P, so we have a dumbbell. This is S, circle, P, a dumbbell. And now these things, these like groups, they have boxes. So S only has 1 box, P only has 3 boxes, and D has 5 boxes. Okay, now let's put that here. So now since we're doing boxes, this would have 1 box, 1 box, 3 boxes, 1 box, and 3 boxes. Okay, now we have to add arrows to our boxes. So since this is 2, I'm going to do 1 up, 1 down. Let me put that more tinier so it's visible. So up, down. 2 right here, so I'm going to have 2, obviously, up, down. Here it's 6, so it's 1, 2, 3, 4, 5, 6. Oops. This is 2 again, so here. And now that this is 1, you only need 1. That's it. Okay, now we're going to classify these. Ready? So this is let me get the color blue. This is a circle, circle, dumbbell, 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 circle. And this is only 1 dumbbell because these 2 are empty. So these we're not going to use. Now we're just going to draw right here. First, we're going to have our nucleus here. Now we're going to put the first circle. So we could check this off. Now we're going to put our second circle, so we're going to check this off. Okay. Oops. After doing that, now we're going to do the dumbbells. So 1, wait, this has to be pretty. 1, 2, 3. Now we're going to do, because you remember that the dumbbell's like this. So we still are missing this half of those 3. So we already did 1 of the halves. So 1, 2, 3. That's it. That's how you do the dumbbells. And now we still need another circle. Okay. And 1 more dumbbell. So 1, 2, 3. And they have to be aligned with each other. And also we do it like this, and we don't do it like that, like the dumbbell, because then it gets disorganized and it's more pretty like this. Okay, so that's it. That's how you find aluminum in the periodic table. That's the electron configuration. Okay, now this is gonna get complicated. Now we're gonna try to find, like, do the whole process we just went through to find, oh wait, why is this, whatever. So, okay, like I said, we're gonna try to find the promethium, which is right here. So this is our goal. So we're gonna find this. So we're finding PM. Okay, so it's the same thing. We're gonna cross these two out. This is in row 1, so 1 S2. Now we're gonna go to this, so 2 S2. 1, 2, 3, 4, 5, 6. 2P6, because you see how now we're in P group. Oops. Now we're gonna go to row 3. 3 is S2. And then 1, 2, 3, 4, 5, 6. 3 S, no, not SP, because it's in group P. 3P6, it'd be the same. So right here, we're still in S, but we're S2. Now since we're going to D group, it's going to change. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'd be 4D10. And now here, 1, 2, 3, 4, 5, 6. So this P group, so it's 4P6. So it'd be 1, 2, because it's 5S2. Now roll D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, 10. 5D10. Now 1, 2, 3, 4, 5, 6. 5P6. We're almost there, but we're still not there. 1, 2. Oops. So 6S2. Again. Ooh. This is where it changes. Okay, so since you have to pass this, and this is connected to the F group, you basically don't have to do any of this, because the atomic number for promethium is 61, and this is 72. So why are we gonna continue? No, since it's 57, we're gonna boom go to F group. So it'd be, or this is considered as F group. It's still in row 6. 6F1. Oh my god. So, like I said, we're gonna cross out 1, 2, 3, 4, 5. So 6F5. And now we're gonna do all those boxes and circles we did on the first one. 6. Okay. So let's go back to where we were. So, okay, we're classifying it. I was like, what are we doing right now? So 1, this is S. So as all the S's just have 1. Okay. The P's obviously have 3. Remember the G is 5. Okay, that's pretty much all of them. Okay, now you see how F, it doesn't have a box? It's because we're not using F. So we're crossing this out. Say bye to F. Bye. Okay. Now let's continue. So remember the little ups and downs? We're gonna do that now. So it's gonna be obviously one up, one down. Same thing. Same thing because it's 6. Same thing. Same thing. It's 6. Remember? Same thing. Same thing. Same thing. Same thing because it's 10 and it's even number. So 1, 2, 3, 4, 5, 6. It's a 2. This is a 2. So yeah, basically all of these are full. Oops. Okay. Label them by the circle, whatever. Circle, circle, dumbbell, dumbbell, dumbbell. Circle, dumbbell, dumbbell, dumbbell. Circle. And then dumbbell, 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 dumbbell. How much is there? 5. Dumbbell, dumbbell, dumbbell. Circle. This is a circle too. Dumbbell, 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 dumbbell. Dumbbell, dumbbell, dumbbell. Now we're going to draw the orbital. So we're going to get all of this information and come right here. Let's make that bigger. All this information? No. All this information come here. So let's see. We're first starting with our nucleus, obviously. Now we're going to do the first circle. Okay. I'm going to speed up this process because honestly, it's super easy and super fast. So I'm just going to, you'll see. So that's pretty much it, and that's the orbital for, and how to find the electron configuration of Protheum. That's it. Ta-da! We're done. I'm done. That's it. Bye.